Jai Shri Ram to everyone. Myself Samprita Kulkarni from Sri Venkateshwara College of Engineering. Today we are going to learn ER diagrams. The topics to be covered in this presentation are ER diagram notations, example and one application in case study. Need of the ER diagrams. First one, database data model design. Uh, The purpose of this model is ER diagrams are essential for designing database data models. And second one, due to diligence and system requirements. Purpose is ER diagrams capture and document system requirements during data model design. And third one, production reference. And the purpose is ER diagrams act as a reference in production, aiding in debugging, optimizing, and redesigning. And fourth one, conceptual blueprint of data flow. And the purpose is ER diagrams provide a conceptual blueprint of data flow within a system. And the fifth one is streamlining business processes. And the purpose is ER diagrams identify redundancies and bottlenecks contributing to the streamlining of business processes. So ER diagram notations. We will see the ER diagram notations. These are the notations we use in ER diagram. Rectangle, it is represents entity, and oval shape represents attribute, and double outline of the rectangle represents weak entity, and underlined attribute is represents key attribute, and this one is associative entity, and relationship, identifying a relationship, mandatory relationship, partial participation, total participation, optional relationship, derived attribute, key attribute. These are the notations we use in the ER diagrams. The most common notations in the ER diagrams are a rectangle. This one represents entity. Ellipse, it represents attribute. Diamonds, it represents relationship. Lines, this is links attributes to the entity sets or entity set to the relationship. And double ellipse, it represents multi-valued attributes, and primary key, it represents key attribute and single valued attribute. And relationship, what is relationship? In ER diagram, a relationship represents as an association between two or more entities. It illustrates how data entities are related to each other within a database. Relationships are fundamental concepts in ER modeling and are crucial for designing a comprehensive and well-organized database. Here is the example for ER diagram. This is the ER diagram for library management system. Here, books, publisher and member, these are the entities, and published by and borrowed by, these are the relationships. Author, book ID, title, price, available, these are the attributes of the book's entity. Public ID, published ID, address, name, these are the attributes of the publisher. And expiry date, name, address, member type, member date, member ID, these are the attributes of the member. In this entity, book ID is the primary key, and here member ID is the primary key in member, and in publisher ID is the primary key for this ER diagram. Let's move further for the case study of the ER diagram for pharmacy store information. In this ER diagram, drug manufacturer, patient, doctor, drug, employee, pharmacy. These are the main 6 entities. And the relationship between patient and doctor is patient seen by the doctor. And drug manufacturer makes drugs. And patients prescribes drug. And drug sells for the price. Then drug sells pharmacy to the pharmacy. Drug will sell to the pharmacy. Then pharmacy work for employee, and drug manufacturer contact the pharmacy. So these are the relationship between entities, and these are the attributes of the entities. We will move further. Here the first entity is a patient. So, in the attributes in the patient entities are PID, this is the primary key patient ID, and name and sex, address, contact number. These are the attributes of the patient, and the relationships are receives the perception with the drug entity and one-to-many relationship, as the patient can receive the multiple perceptions, but the each perception is associated with the one patient. This is the patient entity. And the second one is drug manufacturer. This entity includes attributes like company ID, name, address, and here company ID is the primary key. And the relationships are produce drug with the drug entity. And the relationship is one-to-many relationship, because as a manufacturer can produce multiple drugs, but each drug is associated with the one manufacturer. And the third entity is doctor. And the doctor entity has the attributes like physician ID, doctor name, and specialty. And the physician ID is the primary key in this entity. And the relationships are rights perception with the patient and drug entities. Many to many relationship. As a doctor can write multiple perception, and each perception can involve multiple patients. So that it is a many to many relationship. And the fourth one is drug, and attribute is trade name, and which is the primary key. And relationships are prescribed in prescription with doctor and patient entities. Many to many relationship, because as a doctor, as a drug can be prescribed in multiple perception, and each perception can include multiple drugs, and manufactured by with the drug manufacturer entity. Many to one relationship, as a drug is manufactured by one manufacturer. And the fifth entity is pharmacy, and the attributes are pharmacy ID, which is the primary key, and name and address. Okay. Relationships. Sells drug with the drug entity. This is the one-to-many relationship. As a pharmacy can sell multiple drugs, but each drug is associated with the one pharmacy. And employed by, with the employee entity. This is the one-to-many relationship. As a pharmacy can employ multiple employees, but each employee is associated with the one pharmacy. And the employee is the sixth entity, and it has attributes like employee ID, which is the primary key, and the name. And the relationships are works at with the pharmacy entity. Many to one relationship, as an employee works at the pharmacy, but pharmacy can have multiple employees. So this is the many to one relationship. Then finally, the conclusion of this case studies is this ER diagram models the relationship between patients, drug manufacturers, doctors, drugs, pharmacies, and employees in a pharmacy store context. It represents how patients receive perceptions drugs are prescribed by the doctors and manufactured by the drug manufacturers and sold by pharmacies, with employees working at pharmacy. The relationship captures the flow of information and transaction within the pharmacy systems. I hope you understood. Thank you.